Perfect. Nice to meet you. I'm Seb.
Hi. Let me have a think. I do like a prop though. They've got a debate tomorrow, so they've got all the props.
I saw that they're all having a black or white tie, I suppose, dinner tonight.
They
Yeah.
are.
Oh, that's fantastic.
Are you able to join us?
For dinner, I would have to probably go and put something on, but I'd love to. Yeah. Absolutely. What time is it?
Well, we leave. We've got a coach leaving here at 7:30.
Right.
And it will go on probably till about 10.
Yeah, absolutely.
Drink. It's at Lady Margaret Hall, which is
Yeah.
really lovely.
I'd love to. Yeah.
It's a joint dinner with the Masters in
Well,
Healthcare
I was going to
Leadership.
stay here anyway because I was meeting Mishan Chetty.
Okay.
I don't know if you know him, but he's been working with Chris on developing one of his classes.
Yeah.
And so I was literally going to just hang out upstairs.
We would be absolutely
thank you.
delighted to host you. So
Thank you.
if you're happy to.
Oh, wonderful! Thank you very much.
My pleasure. We have a couple of dropouts. So there's a surprise.
Thank you. Is the microphone on?
Yes.
Yeah.
You happy to introduce yourself?
Yeah, absolutely. That's working. Hi, Noel. Hi, I'm Seb. I hope you don't mind. I've got my telephone recording there. Yeah, but I'll edit you out if you bother.
Do you want me in your?
Well, no, I love it. It's just I don't want you to be upset if that I'm recording. Yeah, love the hat, by the way. Can I wear the hat? No, not at all. No, it's good. I just wanted to make sure that you're okay.
Okay.
Good.
Maybe I'll put more makeup.
Wait, only if you let me. Let me do some too. Thank you.
Did you get your cake?
No, not yet, but I'll have some later. I won't. How do you say your name? Zainab. Yeah, I will do so later. Well, hi everyone. Thanks very much for coming to this, and thanks for allowing me to be here. I think we've got about an hour and 20 minutes roughly between me and your lunch, so I'm sure you'll want me to get on with it. But anyway, so what are we here to talk about? F1. It's pretty exciting, isn't it? That there is a picture of Alpine, the team I used to work for, when we last won in Hungary in 2021. Esteban Ocon ran a fantastic race, and that's me with the trophy afterwards. Unfortunately, I missed it. I was actually driving back home. I was going to watch the highlights, yet another race that we watch at home, and I happened to be driving through through some hills in just south of here, and there was no signal at all, no telephone signal, no radio signal for some reason. And I was having a nice coffee with my son, And when I got back home, I had about 20 million messages on my phone saying, like, "Oh my God, you won," which kind of ruined the race for me because I wanted to watch the highlights. But anyway, but it was fantastic. But anyway, so today, what are we going to talk about? We're going to talk about F1 and what makes F1 nowadays, how, and specifically data, because over the last 10, 20 years, we've been increasingly using more and more data, and now AI and stuff like that. So I'm going to talk to you about how in F1 and also partly in the military and in other places, we've used data and AI in order to be able to do business. But more importantly, I'm going to try and make it as relevant to everybody in this room as possible, and you'll see how as I talk. So, first of all, in good Oxford Said fashion, we're going to start with an exercise. Now, I know you're towards the end of your module, so it's going to be, I can assure you, it's going to be the easiest exercise you've ever done here. And all I want you to do is blink. Right? So on the count of 3, this is going to be easy, right? On the count of 3, I want you to blink. 3, 2, 1, blink. Thank you. Well done. You've all passed. Unfortunately, it doesn't go towards your assessment at the end of this course, but anyway, why am I talking about a blink of an eye? The blink of an eye is about between 0.1 and 0.3 of a second. That's pretty fast. In modern F1, you can fit a whole group of cars inside that blink. And a little bit of math, 300 kilometers an hour, or between 300 and 350, when the car crosses the finish line, is about 0.1 of a second is about 8.3 meters, roughly about a car and a half's length. And so imagine if after a lap, 20 cars after a lap, you blink your eyes as the first car drives past. By the time you've opened your eyes again, another 5 cars have driven past. Real life example, Hungary again, the same place that we won our race last year. In qualifying, the difference between the first, Norris, and the 6th, Leclerc, was only 0.126 of a second. Yeah? That means that 6 cars driven by 6 different drivers in different machines raced for about 75 seconds around the track and finished within 10 meters of each other. Now, why is that important? It's because F1 is all about marginal gains. So it's not the first 70, well, in this case, 74.5 seconds. The competition that we compete, the place where we compete in is that last half a second. All 10 teams, 11 next year, will be competing in that last half a second. And the relevance to all of you here is that in the modern day of AI, is that we're all about to go into this world where it's not about, it's not about sort of large gaps between businesses, but it's about that last little bit of that last half a second, really. Anyway, this is a bit of a word bubble of everybody in the room, and you might think that, well, what's probably some of you thinking like, F1 is a little bit far away from my industry, but believe it, it's not. When it comes to AI, and I'll talk a little bit about how we use data and so on, AI and data, every single business nowadays uses data and AI. In whatever way or fashion, there's no way that we can escape it. And this will be super relevant to all of you, because in the future, you're the leaders of your businesses and industries and in countries that are going to be driving some of these policies, some of these behaviors, some of these companies, the people, the teams, and everything like that. So what you get out of this course and the amazing people that have already taught you is going to be very relevant to this. And all I'm trying to do is give you a few insights of how we have used data and how we manage teams and people, which is the key part in order to be able to drive this little half-second competitiveness. First of all, who is Seb? Why is he relevant? Why is he standing in front of you talking about things that, I know it's all nice shiny cars, but why is Seb actually qualified to be here? A little bit about myself very quickly. I was born in England, very lucky enough to grow up in Chile. That's a picture of me where I spent about 2 months next to a glacier in Patagonia in southern Chile, which spent very cold and wet, but very happy 2 years of my life. After which I came to England, joined the Royal Navy, flew these helicopters, chasing submarines around the world, off ships, and in various weather conditions, mainly in the North Atlantic, which is not very pleasant. After about almost 10 years, I went to university, got myself an education, somewhere not too dissimilar to this. Ended up in Spain with my family, my young family, working in Seville. Seville, if you've never been there, it's a beautiful city. I urge you to go there. And we basically I worked in aerospace on this aircraft called the A400M. That's a picture of the King of Spain trying to get into the aircraft actually. Then after about 10 years in Spain, we came back to England, and through a long process of working in consultancies that you would now know as Capgemini, working in all sorts of industries from data analytics, cybersecurity, automotive, telecoms, aerospace, all sorts of things. I ended up working in Formula One, and initially running the simulator that they were developing at the time back in 2011. And then eventually I had a spell in consultancy, and then eventually my boss calls me back and says, Seb, I want you to come back and take control of take care of the engineering team. It's about 120 engineers. And the problem we have is that we're very good at being engineers, and we love to engineer everything down to the last degree, but we can't seem to organize ourselves out of a paper bag. And I had to remind my old boss that I'm about as technical as this floor. I know nothing about cars. I can't even tell you how clutch works. He laughed, and then he said, "No, well, that's exactly why we need you, Seb. Is because you come from outside of F1, and you will bring all that sort of understanding about people, teams, managing high performance, and so on." So that was about 6.5 years ago, and I've literally just finished it at what is now called Alpine F1. It used to be called Renault, and before that Lotus Renault, and it's based about 20 minutes from where we're sitting here at the moment, up near a place called Blenheim Palace, for those of you who know. Very pretty place. That photograph there is about a third of my team. It started off as about 120 engineers, grew up to about 180, with a peak up to about 205, depending on the time of year. But the point here that I'm trying to make is that initial setting of this conversation is that it is about people. Yeah, AI is a big thing that's coming towards us, but ultimately it is about people, because people manage the strategies, collect the data, and so on. And we'll talk a little bit more about that. Right, what are we going to talk about today? We're going to talk about F1 as, certainly my thinking, is the ultimate data-driven enterprise. Yeah, how we use data from an idea all the way to the track, and how we design and engineer the car using data science. How we use data to make decisions, both tactical and strategic. How we use this data also to do continuous improvement loops, iterative cycles. A little bit about the business of F1 and fan engagement, and the whole impact that likes of Netflix and F1 have taken on the sport, and the new fans that they've engaged. And then, probably more importantly, is the broader lessons for all of you business leaders in this room. Yeah. Starting off, F1 as the ultimate data-driven enterprise is basically, I like to describe it as F1 is like a research and development lab, but at warp speed. Everything in F1 happens at about 3 times the speed of anything out in normal business, because we're always laser focused on making things as efficient as possible. And that's the point here. Yeah. I always put a little quote at the start of every chapter, so I'll let you read those. So, starting, I don't know how well you can read that, but data out of a car is huge. Every single millisecond that car's on the track is transmitting data from about 300 different sensors, all sorts of sources from around the car, from thermal sensors to pressure sensors under the car, which is very important, to pitot tubes, which is basically they measure the velocity of the air, to G-forces, to biometrics in the gloves of the driver to understand what's going on with them whilst they're driving, and the temperature of their body, all sorts of things all over the place, and it's all transmitted back to the engineers and back to the factory. So the point here is that data is not a byproduct of race. It's not something that we just collect and we can think about at the end of the weekend and we kind of sift through it. This happens. It is literally the primary asset that gives us that little tiny edge. yeah, because it's all about marginal gains. Well, we talked about that competition, the last half a second, yeah. It's all about shaving. All the big gains have already been found by all the teams, so it's not about that. That's a given. You wouldn't be competing in the sport if you hadn't. It's about finding those tiny little slivers of things. But more importantly, it's managing the people around the data collection, the summarization, and so on. That's the key point, and that's why it's relevant to all of you. We generate approximately about 1.5 terabytes per weekend, about 1.1 million data points a second, everything from the engine performance to the tire temperature, and that kind of gives us all these sort of data points of when we come in for the pit stops and so on. And all of that is used during the race, also during the preparation for the race, during the race, after the race, and in future to be able to develop cars. We use real-time analytics, which is absolutely non-negotiable because that can allow you to do real-time decisions. Yeah, everybody from the pit wall to engineers at the factory, whilst we're preparing for the racing, that information is very, very important. And from the car all the way through to a screen at the factory is about 300 milliseconds. Now, I don't know if anybody's in banking. I think there's a few people in banking here, but I know that, as an example, I know that some banks have a dedicated fiber optic cable between literally an office in London and an office in New York in order to basically cut down all the lag. And those are the tiny little marginal gains that, for example, banking do. We do the same. We literally look at the best system that we possibly can, and we have all sorts of sort of fail-safes. Like if something happens to the F1 system, that they've got this huge tube, we've got a backup Starlink that we literally swap over. It's not as good, but it's immediate. And as I talked about, the pursuit of marginal gains. Everything in F1 is quite simple. We have only one KPI, one purpose: win a race, win a championship in this case. And the single KPI is the stopwatch. So all decisions in the factory, in the business, refer to how much faster is the car going, how much money per second faster is that car going to be as a result of this decision. And it could be everything from like, do we need to expand the car park? Do we need a new gym? Do we need to invest in a new office like we had to do, to, how much money am I spending on that as opposed to getting a new front wing? What benefit am I going to have? But that's all about the car. But also there's data going to design, engineering, the operation side of things, manufacturing. In design itself, I'm a firm believer of dashboards and data dashboards and so on. So I created all these dashboards that we did with the data that we're having from the project plans and how we're doing things and people and rewards and all sorts of things, so that we could use that to analyze things very quickly, so that we could make decisions and we could actually show that we could have a good understanding of where we were within the project. Are we going to be late? If you're too late to, for example, if you get to March and you don't have a car, you don't go racing. That's as simple as that. So it's not one of these things that, we'll just delay the program for 2 months. You can't. So therefore, all the planning that goes ahead of it is important. And that's why I talk about people and managing engineers, is that engineers, if you leave them alone, they'll just keep engineering until you sort of bring them back into say, like, look, that's just good enough. Now we need you to move on to the suspension. Otherwise, we're not going to have a front left suspension for the car. But also, there's the element that here you'll see a bunch of photographers. There's only so many photographers that can take a nice picture of a car around the track, yeah? But there's always hundreds of photographers. And one of the reasons is that we'll hire something like 12 photographers every race. And one of the things that we do and that we put in place was that literally a system by which any engineer at the factory in preparation for a race could contact the photographers and say, look, can you go to this corner and photograph this car, because I want to see the front wing. And then thousands of photographs would come in, depending on what the engineers wanted, and they would put them through an AI loop, and the AI would sort of analyze the photograph. It would categorize it as per team, per driver, what part of the car, the front wing, the front suspension, the rear, the engine, whatever it was, the floor, anything like that. So such that the engineers could literally look at it almost well, maybe with about an hour's delay, and they could literally see what was going on at the track, which obviously also helps for the future of the design. Anyway, sure.
So which among these data types would you classify as the most important to winning a race if you were to pick the top three?
So we're going to go through that in a second, but it's basically the aerodynamics of it. Yeah, the engines are more or less the same, and next year is going to be all going to be completely different because they have to be 50% powered by battery, 50% petrol, 50% battery. So that's going to be quite a changer. But I would say the aerodynamics of that's why they say aerodynamics is king. So there's about something like 120-ish pressure sensors at the bottom of the car, and the bottom of the car is the one that basically sucks to the ground. And the closer you can get to the ground without it bouncing all the time, the better it is. So therefore, I would say that if you were going to literally analyze one set of data, is that. But we'll talk about it again a little bit more in detail in a second.
The manufacturing piece of the car, or is there some light feed to the drivers to like reach the finish line faster? Is that something you do with this sort of data?
Well, not in that particular case, but the driver have these little screens, and they have lots of data about what gear, what speed they're going at, the delta between them and their qualifying lap, or between the front the people in front and behind, and in some cases it's quite a lot of information. To bring it back to today's world, Lando Norris wasn't doing very well. I don't know how much if you follow this, but Lando Norris, who's leading the championship at the moment, wasn't doing very well this until the middle of the year. And then he said to his engineers, "Please take out half the data because it's distracting me." And as soon as he did that, and he also got another performance coach, but that's a different thing. But then he basically started being undistracted about the whole thing, and then he started doing better. Because he literally couldn't concentrate on his driving. There's so many inputs, and to a certain degree, when you're working, there's a nice parallel actually to engineers. Engineers need to be in a focus, in a zone, if you want. And I'm sure a lot of you have seen this. Is that if you can take away all the distractions that they have on a daily business, per day, then they're allowed to focus into their task at hand. Sometimes it takes people who are working on very complex problems a little bit of time to get into that zone, if you want. And the constant emails, the pings, the Teams meetings and all that just get in the way because you kind of your attention goes off all the time, and therefore you can't concentrate.
So you mentioned that it's going to be half electric, half petrol next year. Is that like a regulation?
Yes. So F1. Basically, the whole of F1 is a technical race. The race is always won at the factory, is a popular saying. The driver is probably the last 20% of that equation, but because everything becomes so close towards this time of the year, the regulations get changed every about 4 or 5 years. So that kind of disrupts everything, and they have to. Oh my God, they have to start all over again. And you're talking about some of the best minds on the planet. So by the time the third or fourth year they've got to the third or fourth year, they've almost all caught up with each other. So therefore they disrupted all over again. And they love doing that because they start all over again and blank sheet of paper, and they start off thinking.
Do these innovations that the F1 teams achieve in their racing get communicated back to their houses, like for the Ferrari team? Does it go to the Ferrari manufacturer and how they build their cars?
Yeah, some of the technology does, but it's not something that we do. It's something that people come and ask us about, and it slowly sort of translates down. Right. Anyway, I'm going to talk a little bit more in detail about how we take an idea all the way to the track, to the physical reality, and how we use data science in car design. So, starting off with, we have. Over the years, the costs of F1 had to be brought down because they got a time just before the pandemic when it was like an arms race. Some of the big teams like Ferrari, Mercedes, Red Bull were spending something like about £400 million a year, which is twice what we were spending, and we were a mid-sized team. and it just became silly. So when the pandemic came, they reorganized the whole thing, and they got to a little bit more sensible levels, and we all have the same amount that we can spend every year, not a penny more, but you want to try and get as close as possible. Anyway, so one of the things that came out of the last 20 years was something called computer fluid dynamics, and that's the top right picture. And basically, it's a supercomputer that has a sea of little virtual air pixels, if you want, and they simulate the air particles going through the air and hitting a specific shape of the car that you can see there on the screen, and how it would behave compared to how it sort of bounces off a part of the car, and how it behaves with the air around it. So you end up building up a picture of what the air does around a shape of a car. And this allows the engineers to try different iterations of different shapes and stuff like that, and they'll tweak one, and then something else will come up here. And generally what you're trying to avoid is little vortexes. You basically want a shape of a car to fly through the air or drive through the air as quickly as possible. So then that creates this little map at the middle right, which is basically slices of air, and you can have this idea of what's happening to the air around it. And the idea again is to try and make it as efficient as possible, get rid of all the little vortexes, and then eventually you will get to the wind tunnel, and where we have a 50% model of the car, which is 3D printed with the parts that eventually they will decide in aerodynamics that they want to try out, and they'll put it in the wind tunnel, and they'll get a picture which you see in the bottom right hand image, which is the comparison between the CFD model and the actual wind tunnel model, and they'll try and correlate it to make sure that that is behaving more or less the same. And if it is, and you've got to bear in mind that each one of these little tweaks that they do in the CFD and the wind tunnel are tiny little millimeters of the shape of each wing or each component of the car. And all of these tiny little things, it's a bit like a stock market graph, you know, it bounces up, bounces down, bounces up, bounces down. But over time, it kind of just goes increasing. It's the same thing. So you're kind of always chasing those little vortexes to try and undo them.
If everybody's using the same sort of machines, like the wind tunnels and things like that, and everybody's given the regulations of what they have to build to, why doesn't it always end up with like exactly the same answer if it's optimizing against?
So this is precisely the point of what I said at the beginning, is that how you manage the teams around it. So I believe you work in Google, don't you?
Yeah.
Yeah. So in the same way that you know, so for example, we will get a lot of data out of what's going on, but the wind tunnel might be old as opposed to new. So there's more technology. Somebody might be able to have found a algorithm or a software or something like that that gives a little bit of a cutting edge. But we're talking tiny little marginal gains. Yeah. And it's about how you manage the people around that whole process. Sometimes, you know, if you don't have proper planning or proper people, or people actually managing these amazing minds, they'll just run off. And I'm sure you've probably seen this yourself. Yeah. And I think that probably a really good example in your world is that I believe that Gemini 3 which has just been launched, has just completely overtaken ChatGPT, hasn't it? And that's completely disrupted the market. But that comes down to how Google has managed the teams of people around probably roughly the same tools that you have. Yeah.
Okay, thank you.
Sorry, just a quick question on this. The whole trouble with porpoising with vehicles, right? So I'm assuming, why wouldn't that have been caught in this phase? And because it seemed to confuse Mercedes and others, but they couldn't understand it.
Yeah.
I'm just curious about, that seems like a blind spot.
The technology. So you see that's a bit where theory and reality diverge a little bit. And when the whole thing came about the porpoising, which is at the beginning of the cars, which is the ground, it is that you as close to the ground as possible. Too close, it starts stalling and it hits the ground. Yeah. And or it gets too close, and it hits the ground, and then it stalls up and it starts bouncing. And in fact, there's an interesting story coming up about that in a second. But no, it's okay. But so that's a bit where in our case we didn't suffer from it too much, because we're maybe 1 millimeter more than Mercedes. Mercedes was cutting it really too close. And they almost painted themselves into a corner with that, because they couldn't quite back out of that strategy without completely messing up their thing. And that's again something I'll bring up in a second, which happened to Red Bull. So, Wayne, sorry, Wayne.
When you're, what's the variance between, because you're optimizing for the car, high performance of the car and the driver, right? And you're trying to get the best performance out of both. When you think about that, do you think about like diet of the driver, sleep?
Everything. Everything. It's about human performance. And you'll hear that the drivers have, their personal coaches, performance coaches and stuff like that. I took that a little bit further in that I said, because we had access to some of these sports psychologists and stuff like that, I said, right, we also always concentrate on the drivers. We've got 100, I've got 180 of the most intelligent, amazing minds in the world, but they're just, burning themselves out. And we're having, we're doing all sorts of well-being initiatives and stuff like that, trying to make sure that nobody was burning out. I said, right, let's bring in some sports psychologists to talk to us about nutrition, good sleep, and don't sleep in the car park. I mean, what are you doing? Because you're thinking that you're working hard because you're young and all this sort of thing. No. You are literally, you want to be at the best version of yourself, but that doesn't necessarily mean like sleeping 4 hours a night, because law of diminishing returns. Act or your job, and there's a lot of really good, interesting studies coming out nowadays. In fact, I was talking to one not so long ago, a guy called Dr. James Hewitt, if anyone want to look him up, who talks exactly about this. So it's all about trying to make sure that everybody is at their best all the time. Right. Anyway, sorry, yeah.
So you're also using analytics from telemetry and all the racetrack information, and also the map, a 3D intelligent map to get the racing driver ahead of the race.
Yeah. I mean, you're trying to do anything as much as possible with the data that you have in order to get that a competitive advantage, really. Yeah. Anyway, so just coming back to this, as I was saying earlier on, the correlation of all this data, and we're down at the bottom map at the moment, is the most important bit. So when we have a design that we think is going to be good, with some, say, 0.2, 0.3 of a second, 0.3 of a second is like Christmas has come early to us, 0.3 of a second around a lap. Remember that marginal gain? If we get 0.3 of a second, we are literally just high-fiving. And we'll send it to the engineers. The engineers will scratch their head, go like, how am I going to make that design a reality? Because it's like the difference between, an architect that says, oh, I want to do this shape of a building, and the engineers go like, really? How are we going to do that? Anyway, so eventually the engineers do their magic, and you end up with components at the car, the track. And at that point, you get the picture, the bottom left, which is the big grids that you put behind the car. Those are tiny little pitot tubes which measure the velocity of the air at any one part of the car. And then the picture in the middle, which is that yellow thing, is called FlowVis paint. So you paint the car with this fluorescent paint, and a little bit like when you're driving through rain and you see the droplets of water coming through the windscreen, and it kind of creates a pattern. It's the same thing. So the idea with that is that you've done all this work, and you've got those patterns of how they works around the car, and that's the physical equivalent of that. So that sends the data back to the engineers to try and confirm that the correlation of the data at the track is the same as when it was the theory. Babatunde.
Thank you. For in Formula One, I realize that there are so many things that are competing. The driver is key part of the competition. The car are also competing, the efficiency, the design of those cars, they are all in the competition. With the effect of AI, are we going to get to a point that because of the AI input into driverless car, that is only the cars competing against the car, or are we going to?
Interestingly, a friend of mine is working in an autonomous racing league in Abu Dhabi, I think it is. Yeah, and they're basically at the starting point of this, and the cars are sort of crashing into walls and things like that, but it's learning quite fast as they're going along. So I think, yes, they will have these races, but I think ultimately part of the F1 is all about having that driver in the loop, because the driver and how they compete against each other and those reactions. That's what makes it an interesting story, I think. And anyone who's watched a Netflix documentary will will probably attest to that. Suma.
Is there a point where obviously the design is created and then it goes to the engineers, and then you said there's the conversation of like, that's a crazy design, how are we going to do it? Is that the point where there's back and forth, and
Yes.
about where there's the compromise? Of
So
of real...
hold on to that thought, because I'll come to that in a second, which is about co-locating teams, and that's a very important point to what you all hear about. So in the interest of time, I'm just going to move on a little bit. But anyway, the whole point of this whole thing is that it's a little bit like, I don't know if you've all played whack-a-mole, where you find a little gain here in the front wing, and then it creates a down thing in the rear, and then you fix that one, and it pops up there and there and there, and eventually it's just trying to get those tiny little increases. So it's always a game of cat and mouse. Anyway, other bits that we use AI for: material science, the strength of materials. We work with companies like DuPont and so on to try and test some of their components that haven't made it to market yet, and we'll basically stretch them, crash them, and all this sort of thing, and give them back all the data. We'll use it for predictive analysis. All the sensors from the car create data, and we can analyze what's going to happen to the car ahead of time if it's going to fail. At the end of the design cycle, so at around January time, when the cars start getting manufactured, we'll weigh it, and generally, more times than not, it's heavier than the theory of what it is, which is about 30,000 parts. And it doesn't matter how well you've sort of engineered it, the physical reality of that component might be half a gram heavier, etc., and it just adds up. So we end up having to do something we should refer to as slim fast, where literally every gram counts. And to give you an idea, a couple of years ago, we were 10 kilograms overweight in a car that weighed 790 kilos. As you'd think, like 10 kilos, what's that? But it's actually, it was quite a few seconds, really. So every little thing counts there. But when you start making a list of what are you going to start shaving off the car, is like, how fast can I redesign that component and manufacture before it gets to the track? Or are there any easy wins, any easy fruit to pick off the tree? And that's where you have to be slightly careful. Then we also use data to do the design optimization. There's increasingly more AI used in order to integrate into the CAD designs that I'm sure a lot of you have heard about, which is where my engineers used to work on, to try and avoid the engineers having to just play about manually, like connecting dots and stuff like that, where in the future, a lot of AI will do a lot of the work. We used to say, like, this is the shape I want, bang, and they'll just come and tidy up things up a little bit, and they'll be able to use their brains in much more productive and more intelligent work, rather than just the manual kind of tick boxing and stuff like that. Eilidh.
Are the majority of teams developing proprietary systems, or are they really using the AutoCADs, the Ansys, the kind of...
Yeah, no. All teams use either CATIA or Teamworks, I think it's called, and they will bespoke it quite a lot. But that's partly where the problem comes in, is that you'll end up sort of painting yourself into a corner. In our case, we had a very bespoke system that we were trying to get ourselves out of, because it literally, we just couldn't do much with it. And certainly you couldn't integrate it things like AI, things that are coming out of AI. So the idea is that you want to try and use it out of the box, but then everybody wants to tinker around with it because they think it's good, but you have to look the strategic side of things. And hence why, for example, I was talking to my old boss, who's the boss of Cadillac F1 now, and they've got absolutely zero problems, because they've literally started from scratch. They've taken the CAD out of the box, put it, and no one is allowed to touch it. Therefore, they can use it without any of the problems that we've had to encounter. Chris.
Just a quick one. Where, from a fabrication point of view, I guess it sounds like a lot of this is almost outsourced or done on a one-time thing. Are you using like 3D printing or anything that's more kind of iterative?
Yeah. So that the idea, well, we use 3D printing quite a lot for the wind tunnel models and so on, but also if we wanted to try something that's non-structural at the track, we will, for example, the roll hoop, which is at the back of the driver, that's what's called a metal sintered 3D part, which is literally created out of metal dust and lasered up. increasingly more and more so. But there's a limit as to what you can do at the moment. We've been working with Boeing for about 30 years on those technologies. Right, in the interest of time, I'm going to go through it a little bit faster. But right, how do we use data to prioritize decision making, both in tactical and strategic side of things? So we use it to do predictive analysis. You've all seen how they'll know that the pit window is between this lap and this lap, because depending on the tires that they're using, is because they know that driving at a certain speed around a certain track in certain conditions and certain temperatures, the tires are basically going to wear out within a very short window. And that's part of the fun of F1, because that starts mixing the whole thing, different strategies. You never know who's going to win and so on. But the difference is that, and this is why I've got the thing at the bottom, human-powered and data-driven, is that the driver is the ultimate arbiter of that. I'll come back to that in a second. You've got obviously real-time updates from the data coming back to the team, so we can make those adjustments. Remember that the cars will go around in a practice run, and they will come back, and the data from that run, they'll be able to tweak the front wing or change the front wing or tweak change the components of the brake ducts or the suspension or whatever, try different iterations of things. And generally it's the driver who will actually also get the final say, like, yeah, actually that felt a lot better, I'm much more in control, less sliding and all of that. And then obviously the critical feedback loop, which is where all that information gets brought back. And remember that correlation. If it all correlates, then all of that information gets put back to the engineers, so that we can make a better use or better design next time. We also use it for obviously rapid decision cycles, and here this is probably a good lesson for all of you, is that coming back to the human element, is that you can have a sea of data, and believe me, we certainly do, but it's how you manage the people who, and the strategy and the execution of gathering that data, summarizing that data, being able to make sense of that data, and so on, as in data science, as we know it nowadays, and how you present that allows the humans to be able to make those decisions faster than anybody else. Some of you might have seen that at the last race, McLaren basically when a safety car came out, they were the only two or three cars that stayed out, and by doing so they lost the race. And that was a decision that was about 2 seconds. That could have taken 2 seconds. Every other car came in, they decided to stay out, but they had, I don't know why it happened, but it shouldn't have happened. But those kind of decisions, if you've got the right information in front of you, it becomes so much easier to make that decision. Prioritization also. It allows you to prioritize things. And this is one of the best things that we put in place. That when I arrived at Alpine, one of the problems that we had was that in my group of in those days 120 engineers, they were all working on different things that they would have been given by the program that they were trying to follow. And then the chief designer, basically the architect, would come out and would go up to somebody's desk and go like, right, I want you to stop doing that. I want you to work on the front suspension. Yeah, but I'm doing this. No, I want you to work on this. Okay, then, chief designer says I must have to do it. And then, next day, the other chief designer for next year's car goes, no, stop doing that. I want you to do this. Yeah, but I was doing, no. All right then. And then what happened was that nobody was working on anything. Everybody was kind of being busy, but not really getting on with anything. Because the chief designers, just like architects, they don't have control of the people, the manpower, the resources. They don't care. They just want to make the best car. So as far as they're concerned, everything's a priority. Everybody work on my stuff. But we had to say, look, we had to put a stop to it. So what we did was that we called it the top 5 approach, which I'm sure you're all familiar with. But basically, everybody has a list of about 100 things in every project you've ever worked with. All we did was say to each chief engineer, right, find 5 priorities that we're going to work on this week. Yeah, but I've got 100. No, but 5. We can't work on 100. We'll work on 5. And we'll work on those 5 and we'll fix those 5. And once those 5 are fixed, we'll go on to the next 5. But make them in order of importance. And then literally we'll concentrate on those 5. And then you end up with something called the Pareto principle, where you end up sort of fixing 80% of the problem with 20% of the effort. And then you start getting into the weeds of other things. So that works really well. But it requires quite a lot of discipline. And a lot of you who will, I'm sure, work with engineers on data and stuff like that, you'll come up with this problem. Everybody's got 1,000 priorities. And it's about not necessarily you making that call. If you need to, you'll have to. But it's making them prioritize their own work, because then it becomes much more focused on what you're trying to do, as opposed to everybody just running off in the same direction. And then you get to the final deadline is, oh my God, we failed. Yeah, exactly. Contingency planning, preparing for all the scenarios that could happen. Yeah, that will that build resilience, the what if scenarios. Finding risk and opportunities. Basically looking for how to mitigate the risks, but also looking at the opportunities. And the point I was making about Red Bull early on is that Red Bull have got this most amazing car, but only 1 out of 20 drivers can drive that car. It's like having a single driver team, which is why they haven't won the championship. They've got Max Verstappen, who's a generational talent, but the car over the years, because he's a generational talent, quite rightly so, they've designed the car around him. But because he likes a very sort of unstable front car, nobody else can drive that. And they've had loads of different very, very good drivers, but they literally, hands up, they just can't drive this thing because he is a very particular way of him driving. That means that Red Bull have painted themselves into a strategic corner, because unless they change their whole philosophy and be able to have a second driver, they'll never win a championship. And that's exactly what we're seeing play out at the moment. Lily.
Yeah, so far I had an impression that there's a lot of data, it's like a quantifier of data, so you can put it into a dashboard and so on. Now you start to talk about the contingency planning, what if, opportunity management. Do you capture this as like a data and then you kind of manage that?
I'm saying more about the fact that you would try and use data to try and understand the risks, try and work through the scenarios. So, like, for example, as preparation to any race or anything we do, we go like, right, what happens if it rains? What happens if a safety car comes out this time of the race? Historically, at the first corner, somebody's going to crash. Therefore, they'll put a safety car. What do we do? The what if happens, all the scenarios, and the more that you prepare as a team for the scenarios, even if it's a just thousands of post-it notes, the more you think about it as a team, what are we going to do if? Then it becomes, and the data, this will be fed by data. The more that you think about it, the easier it will become. Now, a very good example that I'll actually come to in later on, but I'll come back to that point. Yeah. But remember that human-powered but data-driven, and the driver here, the driver can go around a circuit and they'll come back and go like, that one doesn't feel quite right. It doesn't matter all the data you have. If the driver goes like, that doesn't quite feel right, what can we do about it? Yeah. Anyway, just quick interval. I just want to give you another glimpse of quite how thin the margins are in F1. So Las Vegas a couple of weeks ago, Lando Norris won the race. Fantastic, very happy, lots of champagne. Then they got disqualified. So that put the championship out there. Everybody's, oh my God, what's going on? But why did he get disqualified? Him and his teammate got disqualified. That's a picture of the underside of the car. That strip that you see there is called the wear plank. The wear plank is basically so that you don't take out the bottom of the car, which is quite expensive to make. So you do that, and that's what you see the sparks come out at the bottom of the cars. That plank is exactly 10 millimeters thick, 1 centimeter. And you're only allowed around the whole race to wear it down by 1 millimeter. Anything more than that, doesn't matter how little, you get disqualified. Those measurements, 0.1 of a millimeter down to 0.026 of a millimeter, that 0.026 of a millimeter is half the thickness, probably less than this piece here. That's how thin that margin is. And they got disqualified for that. Now those are the thin margins that we're working on. It's quite incredible. Anyway, moving on. continuous improvement and iterative cycles, what we do all the time. And this is where the sort of the R&D lab at warp speed is happening. Yeah. And so you design, you build, you raise, you optimize, always, all the time. You always use that feedback loop, using the data, people, feedback, always marginal gains. What else can we do to make that better? What are the options that I have? Even the tiniest little thing. Can we take a little bit of paint out of the back? Can we shave off that tiny little bit there? That whole feedback from the track of how the air behaves around the car. Do we actually need that component there? Actually, can we maybe halve the weight of it? Do we really need it that strong? Can we take 10 grams, 20 grams, 30 grams out? Always. Learning from failure. When something happens, and this is probably one of the most important things I can tell you today, is that if you can create within your teams a culture of psychological safety, as I'm sure a lot of you have heard the term, it's probably one of the most important things that you do with a team, especially a high-performing team, is that you're asking people to work very, very hard on something that's very, very difficult. In our case, you're asking them to literally go on the edge of what's physically possible on material strength, physics, and so on. So you want to create a culture where people are not afraid to talk up or to come up with ideas or to try things, because they've got a group of people around them that will stop them if they do something silly, but that they don't see failures as, oh my God, I'm going to be sacked, or I don't want to try that because I might fail. It's like, no, we want to fail. We know that we have to fail. The reason I've got the picture there of the England rugby team is that they will practice and practice and practice, and they will fail at lots of things, but they will learn. And the psychological safety thing is about being able to talk to each other about things that are not going right, but without somebody saying like, oh my God, somebody's criticizing me, I'm going to run off to HR to say that I'm being criticized and my feelings are hurt. No, it's about being able to, you people in the room, you'll be able to give feedback and manage your teams of people to create feedback such that it becomes an opportunity for learning. Yeah? So you're talking to people such that, look, this went well, but this didn't go well. I want you to try and work on this because I want you to be better at your job. If you're better at your job, we're better at our jobs, and we'll all advance. And that's what we're trying to do certainly in F1. And retrospective practices also, trying to identify all the lessons learned. We do post-action reviews. I don't know what you call it in different industries, but basically after something's happened, you say, right, what could we have done better? If a component, big component fails, we use root cause analysis. If any of you've seen the Ishikawa diagrams, the fishbone diagrams, where all the contributing factors to why something failed, that will actually bring out quite a lot of really good lessons as to why something's failed. Some things that you might not have even thought about. And it's all about candid feedback. And the reason I've got that picture of, that's actually me in a helicopter back in the day with a submarine and the aircraft carrier in the back, is that the whole point of having something called candid feedback that we'll talk about a little bit more in a second is about being able to have that liberty to talk to people about all these things. What went wrong? Because in our case, if something went wrong, if you didn't have the trust of the people around you and you couldn't be open with them, somebody would die. In F1, it's a little bit safer. If you slam into a wall, maybe a little bit of stiff neck, but that's about it. In our case, it was slightly more dangerous. So you had to work as a very, very sort of close team. Krista.
It feels like what you're talking about here is the agile practice. I don't know if that's something that
Yes. Yeah.
you consciously use and apply with your teams. But yeah, I've used that in my teams, and we use all of these things that you talk about. So
That's very good. Yeah. So the idea is to try and iterate as fast as possible, be agile, as you say, but also be able to have a team where people, where you as manager can create the culture where people can be open and honest about things without feeling criticized, because you're trying to make people better, but a better team, and that's a sweet spot there. Ellie.
When you arrived at Alpine, you described a lot of volatility. So before you got to that continuous improvement culture, was there a phase where you worked through standardizing
the whole process is within that engineering team in order to enable that, or was it less black and white?
Yeah, no, the coming back to the point of why I was brought in is that I had to kind of start from a fairly low base in that a lot of the stuff that is fairly business 101 in most of the world literally had been kind of forgotten because people are just running off to try and make a car go fast. So things like processes, I sort of said, right, can somebody tell me what the process, how we design a car? And so somebody pointed out sort of some PDFs that they'd done many years ago. I was like, right, somebody taught me through this, and they couldn't. So I said, right, first thing we're going to do here is that we're actually going to decide what it is that we do, because if we can't explain it to ourselves, Christ knows how we make a car. So we actually had to go through and perfectly understand things so that whenever somebody came in, we could actually say, right, you're brand new here, and up to then it was kind of like students would come from university and they'd kind of, well, where's the instruction manual? Well, we sort of learn from each other. No, that's not very good. Anyway, we distilled the whole process of designing a car down to 2 sides of an A3, which is literally, that's your Bible. There was also another slightly more detailed one. But the point is that we had to make sure that everybody understood what they were doing, how they were doing it, and have a kind of recipe book if you want. But then there's all sorts of other sides to it, and I'll come back in a minute to it. Very shortly.
When you set up these processes, did you find, I used to manage a quite large design team, we were not designing Formula One cars, we were designing digital products. I found that once I started to processify a lot, and that's how we ended up. But one thing that was lost is like people doing very multidisciplinary things, because when I started to break down, I felt like people ended up with more focused responsibilities, and those like genius creators who are all over the place were lost, and I just felt that maybe a little magic dust was lost in the process.
Yeah, it's sometimes difficult to get multidisciplinary teams to work together, but if everybody, and part of the trick here is to make sure that everybody understands exactly what their role is. If it's unclear what somebody's doing, and this, coming back to Ely's point, this is kind of something I had to do also, is that when, as an example, when I turned up, 120 people, there were 31 different job titles. And I immediately, as a joke, I called myself the chief coffee maker, because it was ridiculous. And I said, right, we're going to bring that 31 job titles down to 6. Everybody's going to have a career ladder. Everybody's going to understand exactly what their job title is, what their responsibilities are. And in order to increase, go up the ladder, this is the job title of the person ahead of you, and this is the development plan, and this is quite important. As a manager, I said, all of my managers, you're going to be personally responsible for the development of each person. I'm going to be responsible for your development. And we're going to have a little contract between the manager, the company, and the person as to how we're going to develop you into that. But coming back to your point, is that if you've got the creator, let's make sure that the creator understands their boundaries, not that they have to run off and help in every direction. In smaller teams and startups, I know it's slightly different in that, everybody has to work on everything, but it's kind of like, it's quite chaotic. But eventually as it grows, you have to kind of try and standardize these things. Otherwise people are never quite understanding what their role is, where are we going, what are we doing? Hence why you have to make sure that there's the clarity of what everybody is doing, what their roles are, where their boundaries are, but also be able to have that communication with the people around them, so they understand that they shouldn't be going like the chief engineer is going to make sure, trying to change somebody's priorities. Like, no, this is where you sit, this is what you do, and so on.
So you didn't feel that there was any trade-off, it was only positives coming from being more process-driven?
It's not, you have to be careful in that if you can process yourself to death, as big companies, I'm sure find out, and this is part of the point I'm going to make it in about 5 minutes, but you have to have a process in order to be able to do something efficiently. If people don't understand what the process is, don't ask them to do something that they don't understand. If you can't explain the process either to people, then you need to sit down and actually understand what you're doing. That's just a maxim, really, of anything we do. You can't just say that, well, we're sort of doing that. That's kind of what we're trying to do. You kind of just work it out. It's like, no. That's the objective. This is how we work. This is what we should be doing. And a little bit about business and fan engagement. I'm going to go through this quite rapidly, but the point of this is that data has also helped transform F1. It used to be quite boring in relative terms. The fan base was about 30 plus and mainly men. Now, with the advent of things like the Netflix documentary and all the data, for example, that you see there in the bottom of all the data that comes to the screen, the fans are much more engaged. On your phone, you can follow the drivers. They've got all sorts of social media. Very, very good point was that when I first arrived in F1, my kids were 11, 9, and 7. I took them to the factory. I thought, well, they'll be impressed with Dad, Took them around the factory, the cars, the driver, all sorts of things. Came back home that evening. They saw their grandmother. Their grandmother went, "Kids, how exciting was that? What was the best part of today?" And they thought about it when like, Dad took us down to a place where I had a machine where you had free hot chocolate. So anyway, roll on a few years and Netflix comes out and my kids go like, "Dad, you never told us it was this exciting." I said, "Well, I've been sort of trying." And then next thing you know is that they're super engaged with, and it used to be the case I'd come back, and those of you who followed my particular team, Alpine, will have known that we had a fair few interesting sort of episodes on Drive to Survive, including some things that we did or didn't do with drivers. And I used to literally drive home and my kids would be expecting, what's going on? I'm reading all this stuff on social media. It's quite fun. But anyway, so that basically brought home the fact that there's a huge fan base now, but it's because the data is being brought straight to the fans. You're much closer to the action of what's going on, and that's super important. Anyway, this is probably my favorite part of the talk here, is some broader lessons about, certainly that I've learned that might be relevant to yourselves. It's about having a culture of data-driven decision making. Yeah, it's all about the data helping you making decisions. Yeah, being able to take that uncertainty away, and the success that we have in F1 teams is literally it's because every decision that we ever do is based on data. Very little, nothing, in fact, is that gut feel. In the past, it was like, yeah, my experience tells me that we should be doing it like this. No. Every decision has to be backed up with data. Sometimes you have to kind of say, right, I've got these options here. Strategically, for me, I'm going to take this decision. A bit like the Red Bull exercise early on, that they should have thought maybe, actually, if we're designing this car, maybe we should think about twice, because only one driver will be able to drive it. But that's hindsight, really. The important thing about data is that you have to ask the right questions of the data, and hence why the people that will work with you and for you are the people that will be asking those questions, and you are the ones who will be guiding them to ask these questions. What kind of answers do I want out of this data? Above all, no silos. In businesses, it's very, very easy to build silos. People love building empires. This is my little area. I don't want to let anybody in, and so on. And it's important that there shouldn't be any silos. Everybody should be able to communicate freely and openly and across places. Sorry, Krista.
Oh, I was just going to ask you to build on that. So how do you create a place with no silos?
Good point. So. Good example here. So we had a factory which was about 30 years old, and the design office was quite large, and it was sort of open plan, but it had these, as you've got the desk, it had these little kind of barriers that you see in every office, which are about here, so you can see the person on the other side. But as you're walking along the corridor, you feel kind of like there's like a little kind of cul-de-sac there, like a little neighborhood of the composite designers. And there's a kind of almost like a psychological barrier. It's like, I need to kind of knock on the door before I go into this thing. You can't stop to talk to this person, but this person is bored because everybody stops to talk to them and not to the person behind them. And so what we did is that we during the pandemic, when everybody was working from home, we said, right, gut the whole place out, and we literally put where before they had their own desk with their little pot plant, and this has been my desk for the last 10 years. Nobody will sit here. We said, right, everybody's got free desking, as I'm sure is the case in most businesses nowadays. And the point was that we said, right, as a whole design, that whole loop, the concept to track thing that I was showing you, we said, right, let's bring aerodynamics in here. And we put aerodynamics, which is literally the center of where all the ideas are created. And we put them straight down the middle of this place. And right on the side of each one of the groups of aerodynamics, we put the relevant engineering teams next to them. And it's all open plan, no little barriers. And literally, all they had to do was that there was a corridor in between, but literally just a walkway like here. And all they had to do was literally cross the corridor and just talk to their mate in aerodynamics. But on top of that, coming to your point, one of the things that I said, and this is, I'm a firm believer of this, is that I got the managers of both groups. I said to them, right, once a week, you're going to get both groups and you're going to go down and buy coffee and I'll pay for it. And I don't care if you talk about the football or the weather, but you're going to start behaving like a team. You're going to go together. You're going to hopefully end up doing sport together. You'll have lunch together. You'll act as a team. And little by little, all those barriers get broken. Because whereas before, aerodynamics were literally a 2-minute walk down to the wind tunnel, and the engineers were always moaning about, that guy, aerodynamics haven't told us about this. Why is that? And the fact that they could have walked or texted or whatever, they kind of couldn't be bothered. So on. Nowadays, now with this whole thing, was that because they were being closer together, now that person's my friend. I'm in aerodynamics and I know something that I know they need to know. Therefore, hey, by the way, next time they're having coffee or whatever, hey, by the way, I just wanted to let you know that I'm doing this. Or how's that going, by the way? Yeah, okay, yeah, good. And all of those kind of problems start melting away. And it's all because you're trying to get communication as close as possible. In Airbus, as another example, we used to call them plateaus. Bear in mind, Airbus has got 4 different countries: Spain, France, Germany, and the UK. I mean, 4 cultures that don't necessarily get on very well with each other. But when it came to designing a new aircraft, what we do is that we fly people into one central area for weeks at a time, and literally put them all together, no barriers, nothing. The boss literally at the middle. And I used to literally I used to dot myself around all over this open plan office, never having one desk at any one time, never an office. I hate offices because that's a barrier. And the idea is that people can come and talk to you. Yeah, people can talk to each other. They get to know each other. They go out for lunch, for walks, for runs, for whatever. They become their friends. And as soon as you break down those barriers, it works. In the Navy, when we used to fly helicopters, coming back to the point of having to trust each other. Trust, in our case, was built in the bar. As in, you got to know, they got to know me and I got to know them better than my own families. To the point where earlier on this year, I was in Southeast Asia, and I saw a friend I hadn't seen him for 30 years. And it was as if it was yesterday I saw him, because we were literally so close for such a short, intense period that we got to know each other very well. And it's all about those kind of things. Coming back to the point of agility that you made, fell fast, fell early, fell forwards. Yeah. We learn very quickly. We don't delve in so much as, why was that? We learn why things were wrong, but we don't sort of go, oh my God, that was awful. Okay, we've failed, we learned, we move on. We'll iterate into the next point. And that's the point about the plateau I made just now. We always invest in the right technology for data. Yeah, that's never that's never sort of a cost that we think about. That's always very important to everything we do. We have something called the cost gap in F1, which is like, I suppose, your CFO, stops you spending too much. If we spend, even if it's £1 more than the cost gap, we get a massive fine. And believe me, the F1, I mean, we literally control the cost down to the penny. But it's and that's why the discipline comes in, like in all businesses, as to what you're spending on. Yeah, that single KPI. As long as the decisions are on that single KPI, what are we trying to achieve here? A few concepts, and I'll go through these quickly because before lunch we've got a bit of time for questions. One of my favorite points about feedback, yeah, is something called Radical Candor. And if anybody's interested in this, there's a guy called Kin Scott who wrote a book called Radical Candor. And this is about how elite teams talk to each other. And we talked about it early on, yeah? It's how you can talk to each other, be very open, very radically candid with each other, but without that whole thing about somebody's criticizing me. No, because I know that in a team setting, or my boss or my colleague is giving me this feedback because we want to work better together. And if you can get that culture, it's a fantastic place to be in. No finger pointing at any point. Really good example in Airbus, when the A380 was being engineered and built, that almost broke the company, because everybody started, the different countries and the different teams were pointing at each other for who was at fault for whatever delays there were at the time. They had to completely change the culture of the whole company. And candid feedback was one of the points that they implemented, so that there was no finger pointing, the psychological safety. This is the next point we talked about. And this is where the leaders of environments, you are absolutely critical in this. You know, people will look at you as the leaders as to how to behave. You set the culture in the same way that the CEOs of companies, and I'm sure we've all lived this, is that they'll set the behaviors. You know, generally in companies you get, you know, somebody from marketing has come up with his most amazing vision, purpose and values and all this sort of thing. But that's, people kind of dismiss it because it's kind of like, yeah, that was marketing team who came up with that. But it's ultimately it's the leaders who have to set those values. How do we want to behave with each other? You know, how do I want people to see, not to see me, but how am I behaving as a leader? Because people look up to their leaders to say how they want to behave. And for example, you will basically, how you behave is what you will allow your teams to you'll get what you tolerate, basically. If you tolerate, and this is not about being a fist smashing sort of leader, go like, oh, you were 5 minutes late. It's like, if you start tolerating tiny little things that people go like, I shouldn't really bring that up, that behavior, and that, you know, that person was being a little bit awkward at that meeting, they were always being a bit snipey. Like, well, you have to basically try and talk these things to people about it gently, but to set the behaviors and what you want. Obviously you want challenges and so on, but you want to be careful with, because people will try and push the boundaries, but it's ultimately it's up to you, the leaders, to be able to set those boundaries, but all within a psychologically safe environment. It's a very tricky thing, very, very tricky, but it's practice. It takes a lot of practice. Believe me, I'm still practicing all the time. It's very, very difficult. Empowering, that's the most beautiful thing ever. So everybody's lived this. I can absolutely assure you, and I've done it a million times, where being the boss, you think that you have to absorb all the problems. And think about it in a different way. And if you're the boss trying to empower people, so somebody will come up to you with a problem. Instead of saying like, oh God, I'll take that problem away with me, and that's another one on your shoulders, that you've got even less time to do the things that you're already prioritizing to do. Turn that problem around. Say like, well, somebody's brought you a problem. What would you do about that problem? Generally, the person who comes to you with a problem will probably have the best idea, or the best idea of how to get out of that problem. So say like, okay, go away and think about it. I think you're on the right track. And when you've got an idea, maybe if you want to bounce it off me, I trust you. Trust. And that's where it's a wonderful thing. If you empower people, especially young people, and give them that responsibility to go and fix problems, it's fantastic. We once had an intern, believe it or not, chair the daily meeting we had in order to fix a massive component that was making us not finish races. Literally, it was an intern on their third year at Bath University who was having to manage, control, coordinate the root cause analysis of a big component of the car. I can't say which one, and they were having to manage the technical director, the chief engineer, heads of department, myself, a bunch of different managers. And this poor kid just was going like, oh my God, what's going on? You know, my friends are in other companies are making photocopies in the coffee. And I said to him afterwards, I said, look, we believe in you. We believe in everybody here. You wouldn't be here if you weren't capable of doing this. You're doing a fantastic job. And you can see this person's pride growing and growing. And he did a fantastic job. Eventually, we got through it, and he went back a different person. He's now actually working at the team. Recruitment and retention. Selecting people is one of the most difficult things I can do, but retaining them is even more important. How to retain people, especially in a high performance environment, literally comes down, certainly my experience, comes down to how you deal with them. If they're in your team, believe me, the most important thing you can do as a boss is take time to talk to them. Get interested. Instead of having a meet, when you have meetings with two people, instead of having a meeting with two people, and I believe this was touched in the previous meeting, go out, grab a coffee, go out into nature, walk in the park. Because when you're talking about a problem, I can assure you that you're never going to have your best ideas in the office. But when you're out for a run, when you're walking around a park, discussing a problem, you go, oh my God, we never thought about that. Maybe you look at a little cloud and you go, oh wow, yeah, that's given me an idea. Or you wake up in the morning and go, oh my God, yeah, why didn't I think about that? I'm sure everybody's gone through that. And also, coming back to the development part, if you take, coming back to this whole sort of how you develop people through the ladder, if you have a personal development plan where you are interested and you've walked through part of your team as to where they're going to be in 5 years' time, and you've got a plan of action of how you're going to get them to that position in 5 years' time, that person is going to be more loyal to you than LinkedIn. They're not going to be reaching for LinkedIn. I've had the case where one of our best engineers came up to me once and said, look, I've been offered this job in a championship winning team and I want to go. I said, okay, that's fine. You go with my blessing, but I need you to go with your eyes open. We have spent a lot of time giving you an understanding of where your development path is going because we believe in you as an engineer. We don't want you to pigeonhole you into this bit in the suspension, but when you go to that other place, they're going to put you, because you're very good at that, they're going to put you right there for the next 5 years. But don't take my word for it. Talk to the person that's coming from that particular team next Monday. I bought them both a coffee, said, right, off you go, walk in nature. 20 minutes later comes back, thank you, I want to stay here, please. Because to them, their development, where they're going in their career is much more important than maybe sort of getting that photograph with World Championship team. And I said to them, look, this is a World Championship team. They've already done everything they needed to be a world champion. You're in a place where we're working up towards that eventual goal. Communication, coming back to the whole sort of co-locating and all that. I cannot overemphasize this. It's about keep people very well communicated. Talk to them about what's going on. Be open and honest. If you don't have trust in your team, we're always open. We'll have debriefs in the race bay, and we'll talk quite openly about some very, very secret stuff because everybody is trusted in that as part of that team. And if they go off and they leak something, well, they're not trustworthy. Eventually, they'll find themselves or they'll feed out or whatever. But be open and honest with where you're going. What are you doing? Don't be secretive. Yeah. Walk and talk, like I said earlier on. When you're trying to have a difficult conversation with somebody, remember dealing with those behaviors. Take them out. Talk to them. It's much more gentle. Yeah. But always be kind when you're talking to people about that. Walk the floor. And I'm conscious of the time. Sorry. Make sure that you can talk to everybody, even if it's uncomfortable. Talk to everybody. If you have the ability to talk to everybody, especially when things are not going well, they'll be open and honest to you about things. Yeah. If you're at a big lofty level and you're not able to walk all the way down and be able to talk to people, you'll never get an understanding, because by the time the problem is filtered through various management levels, by the time it gets to you, it's going to be this rosy, lovely picture, whereas the reality is probably very different. And break down the communication barriers, as we talked about earlier. But above all, you have to have the stable leadership here. Right. Very quickly, use data to stay ahead of the competition. Very important. People use data decisions, as we talked about. Above all, use data to get rid of process. Why do we have to have that process in place? How much time in your day do you and your people spend filling in expense reports or just wading through nonsense emails or stuff like that? I mean, people use AI to summarize meeting notes of the meeting you've just had, or somebody spends 2 weeks making a report only for everybody else to summarize it using AI. What's the point of that? But get rid of process. Look at the process in the entire company. If it's not required, don't let it be there, because that's another barrier to that marginal gain to beat the competition. Question everything. Decision loops, again, make that decision loop very fast. I managed to get an authorization to spend £500,000 inside of 15 minutes within a meeting that was nothing about that. Went from me to my boss to the chief executive. We all, as we talked about, and as we said, you set the culture and the behaviors. But at the end of the day, with all the data you have, it's people who make the companies, but you are the people who will steer them. And trust the process. Once you set the process in place, trust it. It will get you there. Right, in conclusion, have a culture of data and people, have psychological safety, open and honest conversation, very important. Get rid of process, empower people. Be comfortable being uncomfortable. The minute that you get everything fancy and sorted out is when you need to think about the next step. Always be slightly uncomfortable, always feel slightly that you're not quite in control. You're trying to make it better and better all the time. Be radically candid and be a team, work together. No silos. Sorry, I've literally only left about 2 minutes for questions, but that's a link. That's a QR for my LinkedIn. If anybody wants to keep in touch, I'd love to chat to all of you and answer any questions. But anyway, sorry, that was a little bit over time, but have you got any questions? Sorry, then Warren, is it?
Yeah, Warren. Thank you, Sam. I was wondering if you had to distill everything that you've said to us now and put it into what defines your leadership. What has defined your leadership to be successful in such a highly pressured, highly competitive, technologically advanced and AI-driven space? You could encapsulate that.
Well, that's a difficult question, but try and. It's all about the people that work for you. You're not going to have all the answers, so don't be afraid of saying, "Look, I don't know." Vulnerability as a leader is actually a very underrated thing. People think that, oh my God, I need to have all the answers. I'll get back to you on that. Or no, you have to feel invincible. No. It's like, if you don't have the answers, it's an okay thing to do. That's why you've got a team of people. I think Steve Jobs said that I hire very intelligent people to tell me the answers, not to ask me the questions. It's the same thing with us, so I was quite open and honest and like, look, I know absolutely nothing about the car. I'm here for a different reason. I'm here to make you a better team. And so it's very difficult to distill all of that, but ultimately it's about people, how you relate to people. If you look, and I can assure you, if you look after somebody's development, they will be super loyal to you. If you spend time with them, if somebody's done something good, we used to have a meeting every week with all my management and the chief engineers, and we used to say, right, of all the behaviors that we have, who's gone above and beyond, out of the 180 people, who's gone above and beyond in those behaviors? And somebody would nominate 1 or 2 people, and we say, right, not the boss of that person, but one of the other bosses around the table will go and not only congratulate that person, well, hopefully everybody around this table will go and congratulate that person, but one of you is going to take that person out for lunch. And you'll be saying, look, how well you did, and tell me about what you're interested in doing and stuff like that. And that person will go back and they wouldn't have got a bonus, because the money bonus always goes on the mortgage. It's forgotten within a week. But that person will go back and will say that, oh my God, I did this thing, I thought nothing of it, and next thing I know, I've got the chief engineer, the technical director, my boss, and all the other bosses coming to my desk and saying, what a good job I've done. One of them took me out for lunch. And they'll tell their family, their friends, they'll tell their colleagues in other teams, and as soon as you start doing that, and you start developing people or development plans and so on, when I arrived, we couldn't even keep the interns after they'd done the internship, because the culture was not as good as it should be. But within 6 months, we put all these other things in place, and guess what? people used to call us to come and work for us because they heard, oh, hang on a minute, that's a place where, as an engineer, you can thrive. And that's the point. So there's a question down here. Suma?
So we're obviously very tiny compared to this, and we're all data loving people. And we find already that we're like death by numbers. And I'm just wondering, like, I understand you have that single KPI, but how do you look at or process or figure out that pyramid or how to prioritize?
I mean, it's very difficult. It's not something that you wave a magic wand. But you know, in our case, we got 1,000 people. You know, we got dozens of engineers that track and so on. We did start hiring some data scientists and people who did business intelligence. So, like, as a good example, when in my group, we never used business intelligence. I'd used it before, so I went, oh my God, we're sponsored by Microsoft. Oh my God, this is a gift from heaven. I've got business, I can't remember what they call it, Power BI they call it. And so we started developing Power BI. In fact, I taught myself how to create Power BI so I can do my own dashboards. But then we started developing the IT team and creating these things. So that we would sit down once a week and they would say, like, what information do you need? For example, all this data, I can get what information you want. And we'd start, we'd think about it, and then we'd say, oh yeah, can we show this? And then we'd iterate, and oh yeah, this looks better, that looks better. Or can we actually dive into that one? And little by little, you start asking yourself the questions of, what kind of information do I need on a daily basis in order to stop, so that my boss is not asking me 20 times a day, like, where are we the program? No, it's all in that board. You don't have to ask me anymore. It's all there. Then, so it's an iterative thing. But if you ask yourself, what information do my clients need, or do my people need to go and sell to my clients? What is it we're trying to achieve as a business, and how does the data relate to that? What information, out of all this information, can I use in order to help me in those business decisions, marketing decisions, sales, etc. Where am I going to go and find the market, the clients, and so on?
In your opinion, how, if you have all this data and information and all these experts, what happened with these guys that missed 1 millimeter?
That's part of the whole psychological safety thing, that you're on such an edge. I mean, imagine that's such a tiny little thing, that's such a tiny that there were just circumstances that you're never going to, in this case, that they never even foresaw. So that maybe the track conditions are a little bit too warm or too cold, or the tires weren't quite what they're expecting. So you can simulate until, but the margins are so thin that it's very easy to push it too far. And one of the other things that they do is that after every race, you have to be able to get something like 50 CL or 500 CL, I think it is, of fuel out of the car. If it's literally 1 CL out, you get disqualified. That's happened too. So you have to be very careful with how much fuel you use.
So it was a material problem?
No, it was just, so, to be honest, I don't know the answer myself, but it was stuff that they wouldn't have just considered, because there's nothing to tell them that they're wasting the plank too much.
And how technology can support you to prevent that?
I'm sure that people in McLaren are thinking about that. How can we learn? Literally, they would be spending like, what did we miss? What circumstances did we miss? What did we not see? And they'll be thinking about it. They'll be implementing something in the future. Sorry, Olga. Sorry, my eyes not.
Fascinating. Really, really interesting. Thank you for giving the name James Hughes. I love everything you said. And could you give other names of coaches, psychology specialist, or something that any other names that you?
Yeah, I know quite a few. In fact, I met more than one. In fact, I met James last Friday in London. And if you get in touch with me, I can provide some more details.
I just want to ask, right, because I like the way of saying it's data-driven culture, right? But you can actually only create that culture if you're confident in your data and your models. And I think we touched on it with Alberto. One of the things we learned in this course was overfitting. Because I'm sure you said 160 sensors, there's so much data noise. I'm sure it's the margins are small, so the risk is overfitting sort of your data models for specific conditions. And then on the day, there's so many novel things that can happen, whether driver behavior, tires, weather.
Yeah.
And how do you then compensate for those elements where you have then confidence in your race strategy, your models to adapt to the real race conditions?
Ultimately, with data, you're trying to get rid of uncertainty. Yeah. So business is all about uncertainty. My clients, my sectors, my product. Am I going to be able to all sorts of things? So with data, you're trying to say like, this is factual data of what's happening in my business, or my clients, or my sector, or the weather, or whatever it is, and you're trying to sort of take out the uncertainty of some of the things that, oh my God, I'm not really sure about that, but actually now I've got data to support this, so therefore that's one less thing I need to worry about. And it's all about, sometimes you get the data, and it's about, well, can I trust this data? And coming back to Alberto's point, is that, okay, they had data that they thought that they hadn't worn the plank down, but then they actually discovered towards the last 2 or 3 laps, somebody went, oh gosh, we're going to slow down. And in that case, Norris was actually slowing down significantly because they had that thing. And everybody thought it was the fuel consumption. I know it was this. So it's the quality of your data will only be borne out by practice. We think it's this, oh my God, right, so iterate fast, right? We know that was the problem, therefore we can fix it, and therefore the data, we need to look at it from a different angle. I think there was a question, I'll come back to you. Maybe. Was there a question up here before? No? Sorry, I didn't see that.
How much do you trust AI? In sense, you're using the data, using AI to help build things, to improve things, but then you always test. Would you ever have a neural network solution fed into the driver's ear? Or is it always going to be either machine learning or?
I mean, as far as I know, there's no neural network into the driver plan at any time point soon. But how do you trust it? So in a lot of businesses, they'll have their own sort of internal AI network, which is kind of like Chinese walled, if you want, and it will use all the data that you have. But again, it comes down to, well, how do you do an LLM for your internal data? What data do you put in? Do you put in the hundreds and thousands of emails that everybody's written, or the millions of different reports? But data is going like, well, what do I do with this? Because some of it might be relevant, something might be very irrelevant, and how you train those models is very much up to each business. So it's, I mean, to me, one of the things about AI is that with open LLM models is that that's only based on publicly available data, whereas all the data, the important data in the world, sits behind either paywalls or governments or academic institutions, because you don't really want to share that out. And that's really the most interesting data that you want to actually get hold of if you wanted to have proper AI. So AI is only as good as its hallucinations, but so you have to kind of try and set it up little by little. A good point of question was that we had we tried to feed the F1 regulations into the sort of a training base to see if it could find any loopholes. But then it was kind of hallucinating all over the place because we weren't asking the right questions. And it's about trying to ask the right questions within the right context, given this car or this shape or this stuff like that. And how does the AI machine learning thing interpret that collection of ones and zeros of a shape of a car, rather than, because the words ultimately are relationship based of how close they are to each other. How do you translate that to a design? It's not even images now, it's a design, it's a bunch of coordinates, and that's probably the next frontier, I would have thought, but ultimately it's how do you train that, and that's where the human in the loop comes in. So there was a question here, Jacek?
With all this excellence in material science we have, and energy design, for example, are you doing or planning any more scalable businesses using this, utilizing this experience you have?
F1?
Yeah.
So some teams have got advanced technologies divisions. In fact, I was actually offered the job of running ours, but I turned it down. And it's used a little bit, But in the case of AI, I don't think that's yet broken any kind of market. Generally, it tends to be about the use of fast engineering, fast iteration of engineering loops in order to be able to do things. The good example is that any of you who are into sailing, the America's Cup, a lot of F1 teams have got teams of people working on these amazing yachts, which is the equivalent of F1 in the sea. And a lot of that information will be used to be able to translate to other businesses, but it's done as a bit of an afterthought, not necessarily the main objective of an F1 team, because ultimately they're there to win races. So somebody give
last question because we have lunch.
Yeah.
So I don't know if you've heard about the project Gen Beta from Formula E and Google Cloud.
Gen Beta?
Gen Beta, yeah.
No.
So it's about taking telemetry data from a large number of sensors from the car and allowing a live interface for a race driver to interact using Gen AI, using Gemini Flash.
Right.
Yeah, and so the driver can ask something like, okay, what was the turn speed in lap 2, and get live answers,
Yeah.
and then provides his decisions based on the answer that he gets on the screen.
I hadn't heard about that, but that's interesting. Yeah, it's an interesting concept. Although you'll find that some of the good drivers are capable of talking and driving, some of them are not. Some of the better drivers are literally will be taking a corner 250 kilometers an hour, fiddling with the dials, talking to the engineer, thinking about the strategy. I mean, they're just on
the competitors' live feed. So
yeah.
That's important.
So I'm sure that there's people working on that kind of thing. It's like how can we bring some of this data to the driver? That's why the screens in front of them is just so full of data now, which is almost too much. Some drivers just want to concentrate on their driving because they're good at that instead of like having to have 1,000 things firing at them.
Yeah,
sorry, Hillary, I think
Don't apologise at all.
Yeah.
I think we've all learnt a lot from Seb, so a little gift from us. So he'll be out with us for lunch, so any further questions, I think there are a few hands. Perhaps you'll indulge us. Thank you. Just take your microphone. Thank you, everyone. 2 o'clock. Thank you very, very much.
Yeah.
Where did you go, David? What seat did you put your goggles?
What's that?
Where did you put your goggles?
The triangle.
I was thinking about taking a football gin and chilling, but I can't keep that.
Hopefully that's one end because it's really terrible.
Hi, how you doing? Where you started?
Hi, I'm from Brazil. In Chile. Angela, my name.
I grew up in Chile, yeah. Oh yeah, okay, yeah.
That's what my mom was.
I used to work in Airbus, yeah, GKN, I used to work very close to me.
He's going to go for lunch.
Yeah.
Do you want to do you want to go and do your questions at lunch? You all want to
Okay. Otherwise, we're not going to have lunch. We're going to
Take all that